Alright, in the previous video we ended off here where I gave a definition for what an acid is. Acids donate H plus ions to bases. Bases accept H plus ions from acids. Turns out I've been lying to you a little bit. Not a big lie, but a little bit of a lie. This is an equation I showed you in one of the first videos in this section. This is hydrochloric acid. That's an acid. And I said you take hydrochloric acid, you mix it with water, and the H plus splits away from the Cl minus ion, and you still have water. Turns out that's not really what's happening. What's happening is here. You take hydrochloric acid, you mix it with water. The H plus does split apart from the Cl minus, so you end up with Cl minus. But take a look at where this H plus goes. This H plus ends up getting stuck onto one of the waters, and it turns the water into something else. It turns it into H3O+. This is not water anymore. Now, I want to sort of tell you a little bit about what's happening. Imagine that you have a container that's filled with water molecules. It's just water molecules as far as the eye can see. If you throw a little bit of acid in, HCl, there's still going to be almost all water molecules. Almost all of them will stay the way they are. But if you throw in a few HCl molecules, these H pluses from the HCl are going to take a few of these H2Os and convert them into H3O+. So most of the stuff is still water. It's just that every once in a while, when you dump an HCl in, it's going to take its H plus and stick it onto one of the waters, but it's still going to mostly be a sea of water molecules, and then every once in a while there will be an H3O+. This thing has a name. Again, I don't care if you know what it's called, but it's called a hydronium ion. But this is really what's happening, is that you take HCl, you put it in water, and this H plus ends up getting donated to the water. Okay, let's look at this equation a little bit more. On the left side, who is doing the donating? Who is donating the H plus? Well, this is doing the donating because it starts with 1H, ends up with 0. So this stuff must have donated, right? It doesn't have any on the right side of the equation. So this stuff must be the acid. Maybe you can see where I'm going with this. On the left side of the equation, who is doing the receiving? Who is receiving the H plus? Well, it's the water that's receiving the H plus because it starts with 2 hydrogens, ends up with 3. So this water must have received another hydrogen in order to turn itself into H3O+. And because it's doing the receiving, what is the water in this case? Well, the water must be a base, because our definition of a base is anything that accepts H plus from an acid. And well, this is the stuff that's receiving or accepting the H plus, so it has to be the base. So this is a weird situation. It means that water is acting like a base under these conditions. And that's the weird thing about water, is that water will act like a base if you mix it with an acid. And you can probably guess what's coming up. More lies. This is an acid again. And we said this stuff is a base, correct? And we said the acid donates its H plus directly to the NH3 and turns it into NH4+. Well, this is what happens when you take ammonia and dissolve it in water. Remember, we said this is a base. If you mix it with water, the ammonia will pick up one of the hydrogens. One of these 2 hydrogens from the water will get tacked onto the ammonia. It will turn the ammonia into NH4+. But this is not water anymore because it lost an H+. Because it lost an H+, it turns into OH-. So, on the left side of the equation, who is donating H+? Well, the water is doing the donating this time, because it starts with 2 hydrogens on the left side of the equation, ends up with only 1 hydrogen on the right side. Because it started with 2 and ended up with 1, this must be doing the donating. And we already said this one is doing the receiving because it starts with 3 H's, ends up with 4. So this must be doing the receiving. And if that's true, if the water is donating the H plus this time, then under these conditions, the water is acting like an acid. So the weird thing about water is that it can act like an acid if you mix it in with a base, and it can act like a base if you mix it in with an acid. The punchline here is water can be an acid or a base depending on the environment that it's in. There is another point that I want to make about acids and bases. We said that an acid is a material that donates H+ to bases. We said bases are materials that accept H+ from acids. But once the base ends up accepting an H+, it actually turns into an acid because you can run the reaction backwards and it can donate the H+ back. So once the base picks up the H+, it turns into an acid. And once the acid donates its H+, it turns into a base. Let me try and explain what I mean by talking about this equation again. This is an equation from a couple of slides back. This is an acid because if we count the number of hydrogens, it has 1, and on the other side it turns into something that has no hydrogens at all. So this one must have donated, so it must be the acid. But once it turns into this stuff over here, in other words, this is an acid, once it turns into this stuff over here, it becomes a base because I can run the reaction backwards. I can run the reaction from the right side to the left side. And what will happen if I run it backwards is this one starts with 0 hydrogens and it ends up with 1 hydrogen. So this one must have received H+. So if it's receiving H+ when you run the reaction backwards, it must be a base. And the same thing is going on here. This stuff, this is called ammonia, NH3. It's a base because it starts with 3 hydrogens, ends up with 4, so this one must have received. But on the other side, this base turns into an acid because I can run the reaction backwards. And if I run the reaction backwards, this thing starts with 4 hydrogens, ends up with 3 on the other side, so this one must have donated. And this is always going to be true. If you have an acid on one side, once it donates, it will turn into a base. And if you have a base on one side, once it receives, it will turn into an acid. There's a special name for these things that are switching from acids to bases. They're called conjugates. So here's another example. This is an acid, in this case hydrochloric acid. It starts with 1 H, ends up with 0 H's, so this one must be donating. In this case, the water is the base. It's receiving H+. It starts with 2, ends up with 3. But there's a special name for these pairs of things. This HCl is paired up with the Cl-, and this is the base. And these are called conjugates. So this is the acid. This is its conjugate base. Conjugate just means that these two things are married to each other or they're tied to each other. They're related to each other is basically what that means. And this is the base in this situation, and it's related to this stuff over here, and so this stuff is called its conjugate acid. The same thing works in reverse. You can call this stuff the base, and then this would be its conjugate acid. And this stuff over here is the acid, and this is its conjugate base. So this word gets used in your textbook, but basically it just means that the material on one side of a reaction equation that's related to some other material on the other side. So the acid turns into a conjugate base, the base turns into a conjugate acid. So you should take a look at this, pause the video, and basically try to identify the acids and bases on both sides of the equation. And I'm going to unpause the video at this point, or pretend I'm unpausing it. This stuff is the acid in this case, starts with 1 hydrogen, ends up with 0 hydrogens. So this stuff must have donated. And if it's donating, it must be the acid. Now at that point, everything else falls into place, right? This must be the base. This is the conjugate base of HNO3. And if this is the acid, then this has to be the base. But we can sort of reason through this again as well. This starts with 2 hydrogens, ends up with 3. So since this is starting with 2 and ending up with 3, this must be receiving H+, and if you receive H+, you're the base. And the base will turn into an acid on the other side. So we are basically done. If you want to talk about the reverse reaction, we can do that as well. If we run the reaction backwards, this stuff starts with 3 hydrogens, ends up with 2. So this stuff must have donated, which means it's an acid. This stuff starts with 0 hydrogens, ends up with 1 hydrogen. So this stuff must have received, and so it must be the base. And so that's how you should, if I show you an equation like this, you should be able to look at it and figure out which things are acids and which things are bases. So if I show you an equation like the one I showed on the previous slide, you should be able to look at it and figure out which materials are acids and which materials are bases. And that is the end of this video.
Yeah, it's pretty clear I ain't no size 2, but I can shake it like I'm supposed to do. 'Cause I got that boom boom that all the boys are chasing, all the right junk in all the right places.